Hello and welcome to my demo of Trellis, an iOS native mobile application vulnerability static analysis scanner. So here on the main page, it shows you some basic information like the purpose. Basically, Trellis was created to save me a lot of time on iOS mobile application pen tests. I typically spent many hours, frequently many days, doing reverse engineering. I'm not into the type of shallow testing where you like scan with MobSF and then jump over jailbreak and root detection and all that stuff and certificate pinning to get right to the API. That type of shallow methodology typically bypasses a lot of bugs that are client-side in the mobile application. But I wanted to make iOS mobile application testing more reasonable and efficient for the average pen tester who hasn't spent years learning and becoming proficient in iOS reverse engineering like I have. So Trellis will basically do a lot of the work for you and reduce many days of work down to just a few minutes to a few hours of running a scan. And then from there you can take the results and use that information to explore further and validate findings, which I'll be doing a demo on the report here in just a moment. So here on the main page, it shows analysis categories. And let's not skip over the fact that two things here I want to point out. Trellis is not designed to provide copy and paste reports that go straight into a pen test report. It gives you findings that enable you to investigate without having to perform complex reverse engineering. You still have to validate the findings. Also, AI is not used in any way, shape, or form. Your data is completely private and secure. And I can provide a self-hosted option if you want to run a virtual machine on site because you can't share third-party customer mobile applications. In many cases, those have not been published yet, and they're given to the pen test firm in confidence. So we respect that and offer this self-hosted option. Here on the main page, it talks about the different analysis categories and features, and the fact that it gives you actionable reports and exploit verification scripts, which are free to scripts, by the way. Here we also have a link to an example report as well as a few example findings. And I do want to point out that this second example, this obfuscation decode loop, this is very effective at detecting hard-coded secrets. This is a sanitized finding from an actual customer pen test where all the details have been changed to protect their anonymity. And so basically the developers, they tried to hide secrets by encoding them with XOR. And so Trellis detected that there was a hard-coded constant in the data section, and that was later used in a loop construct, such as a do-while loop with XOR. And it basically decoded that plain text secret here. And this actually turned out to be a very high-risk finding, and it was all automated down to just a few minutes of scanning. If you haven't yet set up notifications, you'll get a prompt here, and this won't go away until you actually set one. So I'm going to say maybe later for right now. If we look here in settings, you can copy and paste a pushover key, a Slack or Discord webhook. And the reason why you will want to set these is because these scans, now they may take a few minutes, but normally they may take an hour or as many as 6 hours. So this saves you the trouble of having to go back and repeatedly refresh the page and check. You'll get a notification basically if you set this up. And I do want to point out here that there's a few prerequisites. The binaries must be decrypted. If the application was installed on an iOS, an iPhone or iPad device from the Apple Store, they are by default fair play encrypted, and they can't be analyzed because basically they would just be gibberish encrypted garbage. There is a link here to a tool that can help you decrypt it with instructions. If the customer has provided you with a file like an IPA file that they've sent to you, not through the App Store, then it's most likely already decrypted and you can just upload it. You can upload here the binary pulled from the IPA archive or the full IPA archive. In that case, Trellis will extract the main binary. Supported right now are only decrypted Swift and Objective-C IPAs and raw binaries. Cross-platform frameworks such as React Native, Flutter, etc., those are not supported, although I do plan to add support at least for React Native and Flutter at a later date. If you're in the shared instance here exposed to the internet and you're prompted for a payment, the Analyze button right here would have the price for the scan. Compatibility is checked before your payment is processed, before you're even presented with the payment form. If it's one of these types that's not supported, then it will be rejected and you will not be charged. I also already demonstrated setting a token in settings to receive notifications, and also should let you know that you should be patient because, as I said earlier, the analysis can take anywhere from a few minutes to many hours, as many as 6 hours. It depends upon the size and complexity of the application, basically. And jobs are queued. They're very resource intensive. Some jobs can take up to 16 gigabytes of RAM, so they're run sequentially. Now, after you click the browse or drag and drop your IPA or binary file and click Analyze, it will check it to ensure it's compatible, and then it will start the job and you'll receive notification here. You'll see it in your jobs here. Once it's finished, if you set that notification token, you will be notified. You can sign back in and come over here and click on this to see the logs, as well as download the report or send it to the trash. Your reports and your files are not scanned with any other users. They're isolated to your user account. And once you click to download your report, this is what they'll look like here. So I've already downloaded the zip file and extracted it. In the directory, it's got the main report. The Frida directory has Frida scripts that are generated by Trellis. Now you'll notice there, for each category, there's two files. There's anti-debug here, and then there's anti-debug findings. The ones without the word finding are generic scripts for that category. The ones with findings, these basically target the specific findings found in the scan, which we'll also see here in just a moment in the HTML report. And basically when you run these, it'll print the findings information to your screen for further analysis. If you're familiar with Frida, you can basically just run this Frida script in your terminal, and it will, hook these functions and print out the information basically related to the vulnerability to your screen. You can also edit the scripts to modify return values if they don't print what you're needing. It's fairly simple to do. Frida's documentation makes it easy, but I've done all the hard analysis work for you here in Trellis. You just have to view the reports and run the scripts basically. The JSON directory is all the data that goes into the final report. However, in JSON format, you can use this in any automation pipelines that you create. You could also use it with the help of AI to review these findings from the JSON if you need help processing those. And then, of course, there's the report in HTML format. It's a self-contained report. Everything is in one file. And this is what it looks like. This is a scan of the DVIA v2, an intentionally vulnerable iOS app. And you can see here the results of this scan with the numbers for each risk level for each category. You can click on the link here to jump directly to each section. Here in the string scan section, we can see, let's take a look at this first finding. Hard-coded credential string is referenced by authentication functions. And here we can see that it's printed a string that looks like a possible password. Now, what we can do with this to investigate further is, first of all, we can run the Frida script and it'll print relevant information to the screen about each of these findings. You can also take this address and you can copy that and you can paste it into IDA, Binary Ninja, Ghidra, or Radari 2 to do further reverse engineering there if you choose. But yeah, this looks like a possible password. And Trellis detected that it was referenced in an authentication-related function. So it's a very promising finding. The same with some of these other findings. This looks like a hard-coded password. Down here, client-side biometric authentication in the string scan. So it found where biometric authentication is not bound to the keychain. Okay, let's take a look at another category. I do want to note here the anti-debug and jailbreak detection sections. Let's take a look at those. These are very helpful if you're struggling with bypassing jailbreak detection in an application or anti-debugging behavior, where that basically exits as soon as you start it when it detects that you've hooked into it with Frida or a debugger. This basically points you in the right direction to where to go in your reverse engineering tools to locate these memory addresses, and it actually shows you what they're detecting here. SQLite storage. Mobile applications typically store settings and data in SQLite 3 databases. So here we see that SQLite is using direct execution. If you're not familiar with mobile app testing, mobile apps can be vulnerable to SQL injection through unsafe use of SQLite 3.